So let's just have a quick look at two very straightforward calculations using multipoles, and we're going to do one example for an electric dipole and one example for a magnetic dipole. These are the simplest calculations that we could do, but it illustrates how we would use the formulae that we've developed. Okay, so let's start then with our electric dipole. Okay, so we're going to deal with a situation where we have two charges, a positive charge Q located at Z prime equals plus D on 2 and a negative charge minus Q at position Z prime equals minus D on 2. So our charge distribution then is going to be given by the following formula. Right, so then is the situation, here is our plus Q charge and here is our minus Q charge, and we're going to get the expression for the dipole potential. And remember that the expression is valid when our point of observation is distant. That is, it's large compared to, in this case, mod R would be large compared to D divided by 2. So let's now substitute this expression into this expression here, and then once we've evaluated the dipole moment, we'll put it in here to get the dipole potential. Okay, so then there is our expression now for the dipole moment. You'll notice that it is oriented in the positive z direction, and it's proportional to the product of the charge multiplied by the total distance between the two charges. If we were now to put this in our formula for the dipole, you'll also notice that P is located at the origin, so that's important. So if we put that in our formula for the dipole, alright, so this is the formula, and that is our result for the charge distribution that we wrote down previously. Now, the simplest calculation that we could do for a magnetic dipole would be the dipole moment due to a small circular current carrying loop. So let's take a look at that. Alright, so in this particular case I've put the dipole, the magnetic dipole is at the origin, and the dipole, as I said, will be due to a small current carrying loop. Okay, so our magnetic moment is, we know, is given by the following formula. And therefore our dipole for this small circular current carrying loop at the origin is given by the following expression. Okay, so those are the two most simple calculations that we could do, and we'll explore a few more complex problems than this in workshops and in homework.